Welcome to Lesson 3 for Section 7 of the BJCP training program from the Brewers Anonymous Homebrew Club. We are continuing our section focusing on the ingredient water in terms of beer brewing and in terms of what we need to know for our entrance exam. This lesson is going to focus specifically on alkalinity. This is a lesson where we start to get into more advanced subjects. If you're following along in the BJCP exam guide, you'll probably see that this lesson covers just a little bit more on the subject than is listed in the study guide. Like I explained in the intro lesson to this section, we are expanding these subjects a little more than the guide might suggest to give a better understanding of these points that we need to know for the exam. These lessons are also relatively short on their own. Again, we are breaking them down into those specific pieces to give a better understanding on what can quickly become a complicated subject. All right, with all that explained, let's get on with alkalinity. Now, what exactly is alkalinity? Well, by definition, in terms of brewing and our exam, alkalinity is the water's ability to resist change in pH. Diving a little deeper, alkalinity is the water's ability to neutralize acids and prevent sudden drops in pH when acids are added. Okay, with that in mind, why do we care about that in terms of brewing? Well, this buffering capacity is incredibly important to brewing because it helps maintain a stable pH throughout the mashing process. Now, without getting too far ahead in the course material, I will point out that we will want a very specific pH range when we do our mash. Without sufficient alkalinity, that pH could drop too low. Moreover, maintaining that proper pH level is extremely important for the enzymes that are essential for converting starches into sugars, which is the entire purpose and goal of our mash. Water with high alkalinity can raise the mash pH and potentially hinder that enzyme function. Conversely, water with low alkalinity may not buffer enough, leading to a drop in mash pH and the potential for off flavors in the finished beer. So what's going on in water to actually achieve this balance? Where is this buffering power coming from? Primarily, in brewing at least, it comes from the bicarbonate ion. Bicarbonate ions soak up acidic hydrogen ions that prevent the pH from dropping too much too easily. If you look at this quick image I threw together, it's essentially a sponge for those hydrogen ions. Now, while it can do a lot of this alone, it also gets some assistance from some other elements that are often in our brewing water. Those are carbonate and hydroxide. They don't buffer near as much on their own as bicarbonates do, but their presence does help, and as that old saying goes, there is strength in numbers. Knowing the alkalinity of our brewing water helps us as brewers predict how it's going to interact with the grains in the mash, and how we can adjust it when we need to in order to get the best results we want. And with that, that's it for this lesson, so let's move on to the next.